Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
I'm back! Yay! After 2 weeks. Yes, I was on vacation 1 week. Last week I was traveling, so there was no after hours live stream on either of those 2 nights for 2 weeks. So I took a break from for 2 weeks. I'm doing one tonight. Then next week I'll be on the road again. So I got to decide if I'm going to do a live stream next Thursday night or not. Maybe I need to change my live stream night. Maybe I need to do one on a different night. I don't know yet. I still got to figure that out, right? So, okay, so we always know if you're a regular consumer of this product in the after hours live stream, you know that we always start off with what are you drinking? Because this is an after hours live show, so you can be drinking any adult beverage you so desire. I just happen to be drinking. Where's my drink? Oh, it's back here. I am drinking ginger ale. Yep, ginger ale. See, ginger ale. And if you don't believe me, here's the can it came out of, right? So I drink Zevia ginger ale because it has no sugar. So that's what Chuck's drinking tonight. What are you drinking tonight, TikTok? What are you drinking, Facebook, YouTube, Jim Beam, and ginger ale? Now that's a good drink right there. Ginger ale makes a good mixer. Although I'm not a real big fan of Jim Beam. Not a real big fan of Jim Beam. Just I don't know why. I've never been a big fan of it. So for my people on, let me change this over. Oh, so Tony is drinking coffee. Welcome, Tony. Let me see who else is here. Tony's in the house. Shotzi's in the house. Shotzi is, of course, Dr. Pepper, as usual. He's always drinking Dr. Pepper. So we have somebody else say something here too as well. Hey, Chuck, I was wondering if when deploying PoE Class 4 over 100 feet, if you would notice any voltage drops from using Cat 6 to Cat 6A cabling. I'm downing Buffalo Trace like a bowl man. Buffalo Trace. I don't know what that is. You have to explain to me what that is. So PoE, I'm going to be right up straight honest with you here. I'm not super great with PoE, but I'll tell you my thoughts. And I'll find out. I'll research this answer on the next live stream. I will definitely give you the exact answer on this. But Cat 6 cable and Cat 6A cable. Let's talk about that first. Cat 6 cable is typically going to be 24 gauge. Okay. Cat 6A is generally going to be 23 gauge. Now, when you talk about larger conductors, it can handle more electricity. So Cat 6A will be a better cable for PoE, but is it going to be enough to make a difference for that 100 feet though, right? For that class 4, for that 90 watts? Probably not. But I will research that for you and get you the a more precise answer though for that. Okay. I do have a friend that does a lot of PoE, and I will reach out to them and get that for you. Oh, I forgot to put, let me turn off the chat box here. There we go. And we'll turn on the graphics. So I'm going to put up on the screen for those who are on YouTube, LinkedIn, and Facebook. There's a QR code. Take your phone, scan that QR code, pull up the link. You can have access to all of our social media platforms. You'll find me on LinkedIn and Instagram and TikTok and all this stuff. There's even an opportunity there for you to book a one-on-one 15-minute Zoom call with me, or buy me a cup of coffee, right? help ways to support the show. So for those on TikTok, I'm sorry you don't see the QR code, but you'll see it if you go to the YouTube feed or the LinkedIn feed or the Facebook feed. So it's there, and I'm going to leave it there for now. Right now, let's move on. So next thing we always do after we talk about that is the acronym challenge. Anybody knows me knows I am famous for the acronym challenge. I do an acronym challenge every weekday morning at 8:10 on LinkedIn, Instagram, and Facebook. Right now we're in chapter 19 of the TDMM, the Telecommunications Distributions Methods Manual. Chapter 19 is the healthcare chapter. So this acronym has something to do specifically with healthcare. Now, the reason I point that out is because this whole week has been chapter 19. And one of the acronyms I put out there this week was TDR. TDR. Now, of course, a lot of people, well, Chuck, that's a time domain reflectometer. Well, yeah, it is, but not in healthcare chapter 19 kind of scenario. It's not. It stands for Technology Distribution Room, TDR. Yeah, let's throw the acronym up there. So the acronym for this week is TEC. TEC. Again, remember, it has something to do with healthcare, and it's out of the Telecom Distribution Methods Manual. So what is TEC? Anybody know? I'll give you a second or two to answer that. Let me flip over to the chat box. I see if anybody answers it. TEC. Does anybody know what that acronym means? Oh, by the way, I got to do the my statement on acronyms, right? Here we go. Help control the acronym population. Don't forget to spay or neuter your acronym. We have enough. We don't need any more. Our industry loves acronyms. The only thing it loves more than acronyms is it loves changing acronyms. Yeah. So what is TEC? Anybody? Nobody in the chat box is getting it here. Nobody in the TikTok feed is getting it there. I guess I'm just going to have to give this one to you, right? All right. Kim is in the house. Hello, Kim. Glad to see Kim. I sent out the second book. Okay. So if you happen to get two books, let me know and I'll send you a shipping label to send one back to me. But I did ship it out. Okay. I shipped out the second one yesterday, I think it was. So yeah. If you want the tracking code on that, I got the tracking code for that one as well. So let me go ahead and turn off the what is TEC? Nobody's guessed it yet. TEC stands for Technology Equipment Center. TEC, Telecom Equipment, Technology Equipment Center. And that basically the TEC, it houses the main network equipment and application servers for the data storage devices that serve the basic building. The TEC is the terminology commonly used within the healthcare design industry, and it's kind of real similar to what we call the equipment room in the ICT environment. So the TEC is the heart of the cable and the communication system for the hospital, and it has to be sufficiently sized. It's got to be environmentally controlled, and the power has to be conditioned, and it also has to be fire protected. Oh, Cable Beaver got it on TikTok. Good job, Cable Beaver. Nice. Very good. We're going to turn off that acronym graphic now. All righty. Don't like that one. Would you like this one better? No, don't like that one better. There we go. So there it is. So I'm going to put up the QR code back up again. Remember, you can buy me a cup of coffee or you can schedule a 15-minute call with me. Moving on. So after the TEC, after the acronym challenge, the next thing we always do is the motivational minute. Every Monday morning, I put out a motivational minute. I also do one on the after streams. Here's the motivational minute for this one. You ready? The only person that you need to be better than is the person that you were yesterday. The only person that you need to be better than is the person that you were yesterday. We get so caught up in trying to compete with other people in our industry. That person's got his RCDD. That's how I got my RCDD. One of my friends got their RCDD, and I'm like, dude, if they can get their RCDD, I can get mine. So we get caught in that rat race, right? Right. So you get caught in that. But here's probably the negative side of that is why did that person get that promotion? I've been here longer than them. I know more than them, right? But think about this. What about the person who's watching you saying the same thing about you, right? You need to be a better example for that person, to inspire that person, not through your words, not through your words, but through your actions. Your actions say way much more about you than your words ever will. I'm like, if you ever meet me in person, I'm like that. I pay attention to what you're saying, but I pay closer attention to your actions. I really do. Now, you also, so in order to be better for that person, a better example for that person who's watching you, you need to strive to learn one new thing every single day. One new thing, something big, something small, it doesn't really matter. You should strive to learn one new thing every day. And once a year, you should also pick one new major thing to learn. One new major thing to learn. So again, I'm running another TDMM study group, right? Another RCDD study group. I've got taken another group through the 14th edition of the TDMM because this year I am challenging myself to be better with passive optical fiber networks, GPON and EPON and all that fun stuff. That stuff really came about after I got started teaching, and I never really got a chance to design or interface that stuff. And so I'm making that my challenge this year to be better at that. In the chat box, tell us what is the one major thing that you want to learn next year, right? All right. Let's see. Do I happen to need a crone blade? Yes. So if you're terminating a crone block, yes, you do need a crone blade. Here's why. The 66 block and the 110 block, when you punch down the conductor in that IDC, insulation displacement contact, it displaces the insulation and it actually bites into the copper conductor a little bit. It's actually considered a cold weld. Now, why do you need a crone punch tool? Because the crone punch tool, the crone IDC is at a 45-degree angle instead of a 90-degree angle. So it's a little bit different angle. So you do need a crone punch tool to punch it down with a punch tool. I've never tried to punch it down with a regular punch tool, and it might actually get it in there, but it's really going to mangle it up and make it not work right. So there's the question to answer that question, right? All right, so let's go to the next thing that I had on the list. My list of pro tips. My list of pro tips. So if you ever hear me talking in a class, I give out pro tips all the time. Plus, I just started doing pro tips on TikTok, right, and Instagram. So if you see the thing that says pro tip number 7, pro tip number 25, pro tip number 1, those are actual pro tips that I have documented. And if you want to find my list of pro tips, go to my website, letstalkcabling.com. Letstalkcabling.com. Click on the content tab at the very top, and it's going to pull up a thing. At the very bottom, will say pro tips. Click on pro tips, and you will find my list of 146 pro tips that I've accumulated over the years. 146. Pro tip number 1, document. Pro tip number 2, communicate, right? And so on and so forth. If you read that pro tip list and you think of another one that's really good and you want me to add it, email me. Chuck@letstalkcabling.com. Okay. So there's my list of pro tips. Oh, also, I told you I'm starting to travel again. So next week I'm going to be in Newport News. I'm going to be in Chantilly, Virginia. I'm going to be in right by Baltimore, Washington Airport. What's it, Elkridge or Linthicum? I can't remember. It's one of those two towns. I'll be there. I'm also going to be in Hagerstown. So I will do a 45 to 60-minute meetup after work. So if you want to just come meet me or have questions, you want face-to-face time with me, make sure you shoot me a message quickly within the next day or so. Either email me, send it through direct message on LinkedIn or TikTok or Instagram. Anyone on my feed, shoot me a message. Chuck, I'm interested in meeting you at Newport News, or Chuck, I'm interested in meeting you at wherever. And I'll make sure that I schedule time. If I don't get any requests, as soon as I get done teaching, I'm packing up and I'm booking to the next city. So got to make sure that you talk to me and let me know that you're interested in having that meeting. And then the last thing, and then we'll get into our submitted questions. I mentioned on the last After Hours live stream that we are doing a new t-shirt. Yeah, I'm making a new t-shirt that I'm going to put out there for sale. I'm looking for 5 people. This is for my Instagram, 5. This is for my other people, 5. I'm looking for 5 people to be on my selection committee. And what I mean by the selection committee, my artist has sent to me several designs, And I just want more than one set of eyes looking at this to say, Chuck, I think that looks cool, right? If you're interested in being on that committee, shoot me an email, chuck@letstalkcabling.com. Now I'm going to make you sign a non-disclosure agreement. Okay. So that way you don't grab my design and try to go sell it and make, it's my idea. I'm making money off it. But I will give you a t-shirt for being on that selection committee and a sticker. I'll give you one of these stickers right here. See, just like this. Let's Talk Cabling, right? And I'm thinking that design, the t-shirt design, I'm thinking about also making it into a sticker as well. So if you're on that committee and you want to be on the committee, shoot me a message and then we will definitely take care of that. So somebody already says Hagerstown. Yes, I will be in Hagerstown on Thursday night, August 20. What's Friday? Friday is the 22nd, I think. So Thursday is the 21st, I think. Yeah, so I'll be in Hagerstown on the 21st, Thursday the 21st. So again, if you want to hang out with me, just go ahead and shoot me a message and I'll tell you what time I'll be available and we can have a cup of coffee. All right, there you go. All righty, so there's the meetups. So the first question is from Matt, and this was submitted via Instagram. Okay, so Matt asks me, which is better, solid or stranded conductors for a bonding conductor? Which is better, solid or stranded conductors for a bonded conductor? So before we talk about which is better, first we have to remember what is the overall purpose of us bonding and grounding stuff, right? The overall purpose for the telecommunications bonding infrastructure is basically to equalize the potential between two metallic surfaces, like the ladder rack and the cable tray, right? The primary bonding bus bar and the ladder rack. And it's primarily there for in the event of a lightning surge, AC electrical system faults, electromagnetic induction, or electrostatic discharge. Now, with that being said, now we know that this is for safety. I went to the 607 standard. I have access to the standards through my work, and I don't like doing that because that's their standards. I want to get my own standards. So maybe I should start a standards fund. Maybe I should start a GoFundMe for people to help me buy a set of standards because the standards are going to be, they're like $1,300. They're not cheap, right? So I did look it up in the 607 standard, and it says in 6.3.1 that the conductors shall be copper and they may be insulated. That means it has to be copper. It means the jacket is optional. If you do have a jacket on it, then it's got to match the environment. It also tells us in that paragraph that bonding conductor shall not decrease in size as it moves closer to the point of its grounding source. So it's got to get bigger as it goes back towards the ground source, not smaller. Now, the minimum bonding conductor size is going to be number 6, but there is some verbiage in the standard that says that the telecom bonding backbone, that's the bonding conductor that goes from the primary bonding bus bar to the secondary bonding bus bar, that it's got to be sized at 2 kc mil per linear foot. 2 kc mil per linear foot up to the maximum of 750 kc mil. So if your conductor is 50 feet long, well, you got to take 50 feet multiplied by 2 kc mil, and that would be 100 kc mil. Okay. Now, I did come across one reference section in C.10 in the 607 standard, which says that the conductors can be solid, stranded, tinned, or untinned. Okay, so the standard and the TDMM doesn't really say with 100% certainty that you should use copper or you should use stranded or solid, right? But which is better? Now, this is going to be determined by the current frequency that passes through that wire. As electrical current passes through wires, a skin effect occurs, right? The skin effect is basically just describing how the electron flows on the outside of the copper conductor, right? So the part of the current closest to the outlet of the wire, hence the skin area, is where the electricity travels on that outside surface. And that signal is subject to magnetic fields, and it tends to dissipate in the air. Now, power dissipation is an ever-present thing that you're going to find as an ICT designer or an installer, or maybe even as a customer. Now, because of its thickness, a solid wire has decreased surface area, and that reduces dissipation. Now, because of the given thickness of a stranded wire, basically it's going to be thinner. That means there's going to be more air gaps and more greater surface around the individual strands of that stranded bonded conductor. So therefore, it carries actually less current than a similar solid conductor wire can. Now, each type of wire, right, the insulation technology can greatly assist in reducing the power of that dissipation. So, what type of material they use for the jacket will have a great effect on how that performs. Now, let's talk about in terms of cost and simplicity and durability. The advantage here goes to a solid wire conductor, right? If you're in an environment that's going to be caustic to copper, like for example, you might have the presence of chlorine, then a solid conductor is going to be better than a stranded conductor will be because it's going to take that solid conductor longer to corrode. Now, there are times when a solid conductor might be preferred. For example, like if you're doing a ground ring, basically anytime you put a ground conductor in the earth, that's got to be a solid conductor. But let's talk about the negative sides of a solid conductor for bonded conductors, right? The negative side is they're harder to install. They're stiffer. They weigh more. It's harder to route them in the racks. It's harder to get those nice sweeping bends with them, right? And if you happen to twist a solid conductor, bonded conductor, it's going to be subject to splitting or severing, and that's going to cause you problems. Now, in terms of installation, the stranded conductor wins because it's easier to install, because it's stranded, you can bend it easier. I think it's just as easy to terminate as a solid conductor. So my advice here is just use a solid conductor, and because you can find it's going to be easier for you. Right? Next question. This is from Al on TikTok. This is actually submitted via direct message, not on the live feed on my TikTok feed right now. Al wants to know, what is the shelf life of a patch cord? What is the shelf life of a patch cord? Well, if it's just sitting on the shelf, it'll last forever and a day, right? What causes a patch cord to not work anymore? There's two limiting factors: performance ratings and what's called MTBF. Performance ratings and MTBF. So performance rating means, for example, if you buy like a category 3 patch cord, well, it's already obsolete, so its shelf life is 0, right? If you buy a category 6A patch cord, well, it's backwards compatible. It will work with Cat 6. It will work with Cat 5e. Heck, it'll even work with Cat 3. But that's going to be a very expensive way to do that. The lifespan of an average structured cable system seems to be about 7 to 12 years roughly. So when you design that structured cable plant, you want to design it with that in mind and buy the right patch cords that match the performance of the cable. Because if you buy a Cat 5e and then 6 months down the road, a year or 2 years on the road, you're putting in equipment that needs Cat 6a, well, your patch cords, their shelf life is done. So the next factor in what determines the shelf life of a patch cord, right, is going to be what's called MTBF, mean time between failure rate. Mean time between failure rate. What is that? The mean time between failure rate is the life cycle of a jack or maybe even a mod plug, and it's measured by the number of insertions and withdrawals that jack or that mod plug can handle without it actually breaking. Now, most jacks or mod plugs for telecommunications are generally going to be rated either PL1 or PL2. PL1 is rated for 750 cycles. PL2 is rated for 2,500 cycles. Now, I would venture to guess that most patch cords maybe go through a dozen cycles in their lifespan, maybe 2 dozen, maybe 24 times. They don't go through 750. So it would take a lot of insertions and deinsertions for a patch cord to wear out through the meantime between failure rates. So, there you go. All right, let's go to the next question. Dun, dun, dun. This is from Pat on LinkedIn. And Pat wants to know, Chuck, how can I verify the strand integrity when I grab a spool of fiber in the warehouse before I take it to the job site and install? I just realized I'm not putting the questions up on the thing. Dang it. Okay, I'll fix that. Right. There's a couple of different ways, right? You can use a flashlight. You can use a VFL. You can use an optical loss test set or even an OTDR. Any one of those methods will help you there. But each one of those is going to have a varying level of confirmation. So if you're not looking for documentation, you're just looking for the simplest thing, well, then you might want to go with the optical fiber flashlight, or some people call them continuity testers. And that's basically just a device that generates light in the visible spectrum that we can see it with our naked eye. And you put that light on one end of that fiber and you look at the other side and you'll see the light coming out of it. Now, the light will still go through. It won't go through if there's a major break. a major break. But if there's a break where the cable might have been, so everybody can see it, if it had been stressed and it broke, but then when it came to rest, it kind of come back close together, but they don't quite touch, the light can actually jump through that. So it's only going to work with major faults, not minor faults. And the problem with that flashlight or the flashlight optical flashlight continuity tester, it doesn't give you documentation. It doesn't give you documentation. So the next step up will be a VFL, a visual fault locator. Now, a VFL allows you to quickly identify breaks or macro bends in the optical fiber and help identify poor fusion splicing within single mode fiber and multi-mode fiber. So what it does is, think of it as, I have one. I think it's in my backpack because I'm traveling next week, so I packed it away. It's basically just a laser pointer that you can put on a fiber optic cable, and it'll send that light through. Now, the big difference between the VFL and the continuity tester is the light source and the optical output of the light source. A VFL is typically going to use a red light between 635 and 650 nanometer wavelengths. Now, the optical output for that power light source is going to be 1 milliwatts or less, but still, you don't want to go looking directly into it. So you'll see that red light coming out the other side. The problem with the VFL is it still doesn't give you documentation. So the next one, the optical loss test set. The optical loss test set consists of a power meter and a light source. An optical loss test set actually provides you the most accurate insertion loss measurement on a fiber optic cable by using a light source on one end and a power meter on the other side. And you measure exactly how much light is coming out of the other end. It's actually more accurate than a tier 2 tester. People don't know that. Tier 1, an optical loss test set is more accurate than a tier 2 tester. And here's the cool thing about using that optical loss test set, it will provide you documentation. So you'll be able to look at that. If you know that you're only allowed to lose, 1.5 dB per kilometer, you can verify that the fiber is good. But if you verify you only allowed to lose 1.5 dB and you shoot it and you got 2 dB of loss on it, well, that optical loss test set is not going to tell you where that break is. It just won't. You just have too much loss. So the best way to test it, if you have the ability to do this, is to use an OTDR, optical time domain reflectometer. Now, an OTDR is an instrument that measures the transmission characteristics of the optical fiber, and it does this by measuring the backscatter and the reflection of the injected light as a function of time. Now, it's used to measure the attenuation of the optical fiber, the splices, the connectors. Those are called events. So you can actually take it, shoot it with an OTDR, and actually look to see where those events are, if there are any events. Let me give you an example. Let's say that you have a 1,000-foot spool of fiber in a warehouse, and you hook an OTDR to it, and you shoot it, and you see it's 1,000 feet. But then you see there's an event at 150 feet in from the beginning. Well, you could actually spool off that 150 feet, cut it off, and then shoot it again, and know that the rest of that spool is good, and then take that spool with you to the job site and install it. Plus, it gives you documentation. Pro tip number 1, document. Right? The next question is from John from Instagram. John says, Chuck, I have 2 camera mountings on a pole that will utilize MPTL terminations. The cameras only require 2 pair each. Can I run a single 4-pair cable and split the pairs into 2 separate 8P, 8C connectors? Let me first define what an MPTL is, in case somebody here does not know that. I know you probably might already know this, but there might be one person here who doesn't know it. MPTL stands for Modular Plug Terminated Link. So if you have a wireless access point, a camera, a security device, an industrial sensor, where it's not safe or not feasible to put a jack, then you're allowed to crimp the mod end on the connector and plug it right into the device. That's an MPTL. So the answer to John's question is, can you split a single 4-pair cable into 2 MPTLs? The answer is yes and no. Yes, you physically can do it. And yes, it might work. But no, it's not recommended for the way to install it. Now, the 8th edition of the ITSA manual, the Information Transport Systems Installations Methods Manual, the Bixie's book that they just published at the beginning of this year, and it talks about how to do this. It gives us 6 great reasons why you shouldn't do this. Number 1, it may not comply with the code or the authority having jurisdiction. I can't think of anything in the code book off the top of my head that an inspector would key in on and say, no, you can't do this, other than it's got to be done in a neat and workmanlike manner. That's the only one I can think of that they might try to nail you on. The second thing that they give you in the ITSA manual as to why not to do this is it prevents proper testing and certification of the cable performance. Remember, the standards are written so that that cable will work with all computer systems out there, all phone systems out there. If you start splitting pairs, it's only going to work with some computer systems, some phone systems. The third reason they give you is it increases the difficulty in troubleshooting link cabling performance issues, right? The fourth reason they give you is it reduces the options when it comes to upgrading the equipment. Yeah, so what if you have, so the camera they have today only needs 2 pair, but what if they go to one that they want to have a pan tilt zoom motor in it? Well, that needs more conductors. Well, you only have one 4-pair cable going there. You're limiting your options in the future. The fifth reason that they give us in the ITSA manual is it increases the work required for moves, adds, and changes. And the last one they give you is it often invalidates cable warranties. If you know me, you know my day job. I work for a manufacturer. I don't say who it is in my podcast, but you probably know. If you know me on LinkedIn, you know who I work for. That will absolutely void your warranty. Absolutely void it. Now, when installing new systems and replacing existing cabling, splitting of the pairs should be avoided and only be performed if the system manufacturer requires that practice. Okay? Only if the manufacturer says that's the way that you should do it. Okay? Last question. I know we're already 2 minutes over, but I have another question here. And this one's from Gary at Patreon. By the way, did you know, besides clicking on the QR link and buying me a cup of coffee or scheduling a 15-minute Zoom call with me after hours, you can also become a Patreon member and support me that way as well. Patreon members get special access to me for questions. They get my actual phone number. They can call me and shoot me text messages. All right. So Gary asks, I learned recently what NVP is and why it's important. What do I do if I don't know the NVP of the cable that I'm testing? First, again, I don't want to assume that everybody here knows what NVP stands for. So I'm going to explain it. It stands for nominal velocity propagation. The textbook definition of NVP is how fast the speed of light travels down a cable in relationship to a speed of light in a vacuum. It's generally defined as a percentage. The NVP for most communication cables runs between 0.64 and 0.75, right? So if you have a cable that has 0.71 NVP, that means if you want to find out how fast the electron travels, you can grab your calculator and you can put in the speed of light, which is 186,282 times 0.71. You'll find that the electron travels down the cable at 132,260 miles a second. Now, why is that important? Because the way we find out the length on a cable is it sends a signal down the cable because of a mismatch of characteristic impedance. Some of the energy gets reflected back. If we know how fast it goes down on the cable and back, we can use a mathematical formula to figure out exactly how long that cable is. So it helps us to get the most accurate cable length if you know the correct NVP. You can find the NVP in the catalog. You can find it sometimes on the spools, right? But unless there's a specific company policy, or maybe the customer requires, or maybe the manufacturer requires it, you can use the generic setting in your tester. Now, I got the AEM Test Pro back there. I can't really do it on the screen here, but there's a way you can actually go into it, and you can go through what's called Determine NVP. You're going to need a piece of cable that's a known length, at least 50 feet. And then you tell the tester it's 50 feet. You'll shoot it down it, and it'll come back and say, oh, the NVP for this cable is whatever it is. So there is actually a way to field test NVP. But again, unless there's a specific requirement for it, just use the generic setting in the tester. And most of the testers have a database in there anyway. You'll probably find your specific cable in there. Now I did work for a company at one time that they actually wanted us to set the NVP for cables on projects larger than 100 cables. So there's always that too, right? So that was the fifth question that I had submitted. Let me flip over to the chat box real quick to see if anybody has submitted question. There's one here. If you're running 2 IP cameras and want to use one category of it, can you use a pod combiner? Can you use a pod combiner splitter? So yeah, you can use something as long as it's external to the cable plant, right? So for example, this is not what you would use, but you kind of get the idea. So let's say I have two telephones, but I only have one 4-pair cable. The two ways of doing that would be to put 2 pairs on one jack and 2 pairs on the other jack, or I could terminate all 4 pair on one jack and use some kind of an adapter or a splitter to make it go into 2. So yes, so the splitter thing would be fine in that scenario, as long as it's outside of the cable plant. That was a great question, Big Daddy. All right, let me check here on the chat box to see if anybody has submitted. Anybody submit any questions there? So somebody's talking about the Crone here. Oh, no way. I thought it was more of a EU thing. So Crone has a long history. It did start out based in Europe. And I remember when they first came out, I actually just told the study group this last Tuesday, or actually 2 nights ago, whatever Tuesday was. Today's Thursday, right? Tuesday, yeah. I remember when Crohn's first came out because they claimed to be way better than 66 blocks, way better than 110 blocks because they were silver plated, not bronze plated. Silver conducts electricity better than bronze does, and because that IDC was a 45-degree termination. That way, if you were trying to identify a cross-connect cord out of the thing, you wouldn't pull it out of the jack because it's at a 45 instead of a 90. So they claimed it was better, and it was a Europe thing. But then Crown got bought out by Comscope, I think it was. I think it's Comscope. If you know who it is, let me know. I can't remember off the top of my head. But somebody bought Crown, and now they don't make them out of silver anymore. They make them out of bronze now. So, kind of took away the thing that really made them bad. So somebody on TikTok says, "Hey man, love your content. Thank you very much, Mr. Terra Nova Tech. Are you in Northern Virginia, Terra? If you are, I'm coming to Virginia next week. I'm coming to Newport News, Chantilly, and a couple places in Maryland. So if you're in Northern Virginia, you want to do a meetup, direct message me. Okay. Alrighty. So we are 6:37. I went 7 minutes past my 30-minute stream. Oops. Sorry about that. All right, everybody. Keep your eyes out. I'll let you know if there's going to be one next week, a live stream next Thursday night. Kind of depends whether I have people. That would be cool. I just had a thought. So if I'll be in Hagerstown, maybe I'll do the after hours live while I'm in Hagerstown with people. Oh, that would be so cool. That would be so cool. So yeah, if you're in Hagerstown and you want to do the meetup thing, let me know and we'll do the live stream there. We'll do a live after hours with a group of people. That'd be really cool. So until next time, everybody, remember, knowledge is power.